You're watching Power Nation. It's a busy day for engine power. We get started on an LS3 stroker designed for big power on pump gas.
Plus, we get our hands on a state-of-the-art crankshaft balancer.
Today we have a very cool and exciting build on this engine. And like all projects, this started out with some sort of budget. Well, something changed, and then that affected this, and one thing led to another, and now the budget is blown. But for how much power this is gonna make and how good it's gonna run on 93 octane pump gas and who's actually gonna be hammering on it, we have to put some very high quality parts in this billet to make it last for the long run. It all starts with the parts we have laid out on the table, beginning with a Summit Pro LS 4340 forged 4-inch stroke crankshaft, and we're holding everything together as usual with ARP fasteners. We also have a full complement of Comp Cam's valve train, including one of their hydraulic roller camshafts, their new Evolution lifters, and a bronze thrust plate with a billet timing set. For our pistons, we went with DSS. They made us a custom set of pistons with a dish to our specifications, and they will be sealed up by a quality set of Total Seal AP profile piston rings. Hooking those pistons to the crankshaft are a set of Eagle H-beam 4340 forged rods with 7/16 L19 bolts with a 6/125 center to center length.
We've done our fair share of LSs, and normally they are of the iron block persuasion because they're relatively cheap, easy to get, and they hold a great bit of power. But this time, to save a little bit of weight and to do something a little bit different, we are going true LS with an all-aluminum LS3. Now this one has a little bit work to be done, but so far it's been bored and honed to a final bore size of 4-inch 85 thousandths, and with our 4-inch stroke crank, that's going to equal 419 cubic inches. Now with any stroker build, the most important part is mock-up. So that is what we're going to tackle first. Make sure we don't have anything that hits anything else.
It's going to.
Probably. We'll temporarily install the King Racing main bearings in the rear, middle, and front saddles. The front and rear will support the crankshaft, and the thrust bearing will keep it located during mock-up. These are used stock main fasteners torqued to 55 pound-feet for now.
I like it.
Well, it's just for mock-up, so just enough to make the housing round good enough.
But it has to have torque on it because otherwise the bearings won't have crush.
Yeah, and
therefore the bearings won't be round.
Yep. One of the rod and piston assemblies is dropped in without rings, and we rotate the engine to check for interference. If we're lucky,
well, we are not
we're not lucky.
We're not going to be lucky on this. We'll use a marker to trace where the rod hits the block on the number 1 and 2 cylinders. If you need to clearance the block at home, you can use a carbide burr, but we're going to put our block in the Vectrex mill to make quick work of it. To ensure the cuts are consistent and accurate, the block must be precisely located in the mill. To do this, we'll use our SPI dial indicator chucked into the quill. To get plenty of clearance, we chose a 3/4 inch diameter 4-flute end mill. To make sure we don't overshoot things, several light passes are made to get the correct clearance depth. Once the first clearance notch is complete, we move down to each cylinder following the engine's bore spacing.
To prep the block for deburring and cleaning, we'll drive out the cam bearings. Next, we'll take a small hand file across any sharp edges, just enough to round them off. This helps prevent stress risers and tearing of the skin or rags during assembly. On the less crucial areas of the block, we'll use an 80 grit cartridge roll. Since this block is aluminum, I'm using a light touch and letting the abrasive remove a small amount of material. Then, the threaded oil gallery plugs come out. Finally, the block goes into the jet washer for initial cleaning.
Up next, Randy Neal shows us how to balance our crankshaft to perfection.
Then it's back to work on the LS3.
How's that look?
It's pretty cool.
Get out of there.
A couple of weeks ago, we received a piece of equipment that brings us one giant step closer to being a fully stocked machine shop. Just as important, it gives us the tools we need to show you the science behind one of the most critical parts of high performance, high RPM engine building, crankshaft balancing. This is CWT Industries Multi-Bal 5500, a 4,000-pound beast designed for precise, accurate crankshaft balancing and adjustment. Once we got the balancer into place and leveled, we outfitted it with everything we would need. To help us get going fast, we had no less than the founder of CWT Industries, Randy Neal.
Tell us a little bit about balancing. Balancing is one of those things that people think there's a lot of voodoo to it, and I don't know if I've ever heard anybody say it better. It's science.
A lot of misnomers. Some people would define it as voodoo. Well, the fact of the matter, all balancing is cored within the law of physics, right? Let's call it science. The problem that we have in industries is that lack of knowledge generates false procedures, AKA voodoo. We really have done a deep dive to make sure that anybody with just a reasonable amount of talent, you can run this machine.
You are the designer of this machine. What makes this machine built different? Obviously, you know, we moved in here, it was super heavy. You know, this thing's 4,000 pounds.
Well, we've learned that rigid is a factor, but dampening is more of a factor. So as we measure rotationally, we generate energy. It's important that we find the energy here, not contributed or polluted, I should say, by other inputs. We're very unique. Our algorithms, which are proprietary, they basically understand thermal growth. They also understand the vertical loads. They know all this stuff. And again, doing it back here, you don't need to know this stuff. It does it.
Wow.
Let me just show you something. Let's see if we can do something real quick here. And this is on the left stanchion over here. Now, I'm gonna have you just touch that, Pat. Just touch it. That's you.
Wow.
Okay? Now, in doing so, every time we rotate, it gives us what's called a sinusoidal wave. All right, so as this rotates, it's sensing that. But what's unique about that is the level of sensitivity. Now, I want you to go ahead and touch at the bottom. Go ahead. Go ahead. Nada.
Wow.
Okay, so we have totally isolated all of the energy right here. This is all about measuring accurately and simply. And you'll find as we interface with this, we build the bob weight card, and this thing will hold over 20 million samples.
Wow.
Right? You fill that up, I'll give you another computer. No charge.
The first step, and one of the most critical, is to gather everything that will make up the rotating and reciprocating assembly. The Multi-Bal 5500 has a really helpful feature. Once you weight a component, you simply hit the print button on the scale, and the computer builds the bob weight card for you as you go. After numbering the pistons, we weighed them, along with the wrist pins, locks, ring pack, and bearings. By entering a description and part number for each component into the computer, we'll have a permanent database of everything in our engine's rotating assembly.
While Frankie finished up the bob weights, I attached the drive belt to the crankshaft and indexed it to the machine.
After spending several hours showing us the ropes, Randy had to hit the road, but he gave us the tools and knowledge to get the job done. We spun up our crank for the first time, and not only was it imbalanced way above our tolerance, the location of the imbalance was not ideal.
Because of those results, this makes this crank a little bit more challenging to balance, because where it wants weight removed is a place where we actually can't remove it. It's not on a counterweight, so we have to change where that imbalance is located.
And the way we're going to do that is actually add material. So we've made some steel slugs. Both will be pressed in, one in the reluctor wheel here and the other in the front counterweight. We'll get them pressed in place and then fully weld them for extra insurance. To make them a little bit easier to install, we've had them sitting in the freezer for a while.
Right next to my ice cream.
Grab two. These steel slugs have a 1.5 thousandths press. To support the reluctor wheel and provide a stop for the slug, we slid in a feeler gauge. Oh yeah.
Glorious.
For the front insert, it is crucial that it be welded in place, since centrifugal force will constantly be trying to turn the insert into a high-speed projectile. For extra insurance, the back slug is welded in as well.
All right.
All right, ready?
Yeah, spin it.
Spin it.
After spinning it again, we're much happier with the results.
So now we're
There
on
we go.
opposite sides. So
Yep.
we go to the
Roll it
back
now.
here, we'll roll this back and wait, and that at 2.796 grams.
I mean, yeah, that's within 6 degrees of 180,
Right.
which is just what we wanted.
Right.
And the back is really close,
Right.
and the front is, we overshot it a little bit, but that was kind of on purpose because it was in a place where we couldn't get to, so now we've overshot a little bit, and now we can just work it down from there.
We started grinding on the heavier end, which was 27 grams over. We worked on the counterweight to remove about half of the excess mass. After several times grinding and re-spinning, we are able to get the crank dialed in just right.
Yeah, baby,
Oh,
look
yeah.
at that.
Wow, that's perfect.
Now that
almost.
was like totally not by accident, but kind of by accident because it's so close. 0.1 ounce inch and 0.1 away, 8 thousandths of an ounce of an inch away, and our balance tolerance, 1/4 ounce inch.
They're almost directly 180 degrees apart from each other, so that, in terms of forces on the center of the crank, that
Right.
really minimizes it down to 0.147 grams. So that's really nice. This is either side here, but this is what we started with. And, even at, we'll say 7,000, that's probably the most this crank will ever see, 122 pounds of force on the left side and 124 on the right.
Before we
started,
Yep.
now we've minimized that down to 8 pounds and 9 pounds. And that progressively gets, larger with RPM. So the more we
Right.
can minimize that, the better it's going to be for the engine in terms of bearing wear and life and things like
Yes,
that.
it makes everything look better. That's pretty happy. And the best part is no holes. We actually
Yeah.
profiled after we were done. We knew what our weight was going to do for the most part. And then the less holes you can have in the crank, the better it is for windage.
Yep.
And there's a couple
Yeah.
other things.
Not only does it just look nice, yeah, it actually performs a little bit nicer too. So
It looks nice, but
Yeah.
that is pretty spiffy for our first crank on our machine, huh?
good job.
Nice
All right,
hustle.
Print these right out and then get this sucker off of here.
This is just the tip of the iceberg. We'll explain a lot more balancing tech in the future. Up next, to build a high-performance engine, it takes planning and the right parts.
Before we continue on with our project, I'd like to clear up something that you may be confused about in crankshaft balancing, and that is the difference between external and internal balancing. External balancing considers it needs everything hooked to the crankshaft to get the shaft to balance. The counterweight itself is not large enough to counteract the bob weights total, so we need extra weight on the crankshaft so it moves that weight for removal back onto the counterweight. And that can be accomplished by using a combination of the flywheel and balancer, or maybe one or the other depending on the application. Now, internal is totally different. It doesn't depend on anything like the balancer or flywheel for balancing. Everything is contained on the shaft. The crankshaft counterweights have enough mass and material to counteract the bob weights total without the need to add external weight via the flywheel or balancer. There is a lot more information concerning balancing, and if you have any questions about what would be right for your application, you can always consult the experts at Summit Racing Equipment.
Now that it's been balanced, it's always a good idea to run a polishing belt over the journals of the crankshaft. We're using the Goodson crank polishing tool and a cork polishing belt to get a better than factory finish. This is a task that is usually handled by the machine shop after the shaft has been balanced. Looking good.
Next is a crucial part of any high-performance engine build. It's something we don't always show you, but we always do it. We're talking about wrist pin vertical oil clearance. This is very similar to measuring main bearing and rod bearing clearance. After measuring the wrist pin, we'll use the micrometer to zero out a small dial bore gauge. This instrument measures to 10,000ths of an inch, and we're looking for between 0.8 and 1,000th of clearance for this application.
Before the rods and pistons go through the final cleaning process, we'll engrave the cylinder number in each one so they are permanently marked. The rods and freshly polished crank go into the jet washer for 30 minutes at 150 degrees. Once the pieces are clean, we'll let them cool off to ambient temperature. This is important because all of the components and measuring tools have to be the same temperature for accurate measurements. For this application, we're using a set of King Racing XP bearings from Summit Racing Equipment. Because the bearings are narrowed, they must be installed in the correct location so the bearing's offset clears the radius on the crankshaft.
Connecting rod bolts are the most critical fastener in an engine because of the environment and stress that they have to endure. This makes picking the material they're made out of very critical. ARP is the leader in quality connecting rod bolts, and they have a couple different choices when it comes to the material for your build. You've commonly seen us use 8740 and ARP 2000 materials. 8740 has a tensile strength of around 180,000 psi, which makes it a great upgrade over an OEM fastener for stock or mild applications. ARP 2000 is much stronger with a tensile strength of around 220,000 psi, and this makes it a great choice for rod bolts, main fasteners, and head fasteners in high-performance, high RPM builds that are well maintained. For our application, because we're looking for extreme durability and longevity, we picked L19 fasteners. Now these are much stronger. They have a tensile strength of around 260,000 psi, but they do take some extra care. Because the material is really susceptible to stress corrosion and hydrogen embrittlement, it's really important that when the material is clean and dry, you don't actually touch it with your bare hands because the acids can help induce that corrosion. It's also important that they're not cleaned with any chlorinated cleaners like brake clean. We've gone ahead and cleaned ours with lacquer thinner, and you can, if you're careful, get away with touching the bolts if they're covered in oil and your hands are covered in oil because it gives a protective layer between your skin and the material. But a lot easier and much better way is just to use some gloves. ARP Ultra Torque Assembly Lube goes on the threads and under the head of the fastener. To prep the rod for checking oil clearance, the bolts are torqued per the manufacturer's guidelines to achieve the appropriate rod bolt stretch. Checking the vertical oil clearance is the same as the process for the wrist pins. Once the mic is set to the journal, the dial bore gauge is zeroed out and we can get a direct oil clearance measurement. They all come in between 24 and 26 10,000ths. Exactly what we wanted.
Once the rods, wrist pins, and pistons are thoroughly lubed, the wrist pin slides into place and the rod is worked back and forth, making sure the assembly lube is properly distributed. The wrist pins are retained with dual spiral locks, which gives a little extra insurance and are relatively easy to install with some care and patience.
Up next, we finish up the short block with a forged rotating assembly.
We needed a set of piston rings for our DSS pistons, so we reached out to the guys at Total Seal, told them the specifications on our piston and the application that the engine will be used in. They specifically recommended a set of their conventional AP steel rings in a 1.2, 1.2, 3mm ring pack. The top ring is made of 440B stainless steel, which is going to be stronger and have a much longer lifespan. It has a C33 face coating, which is going to prevent dirt and debris from penetrating the coating, which could affect ring seal. It also goes through their advanced profiling or AP ring process, which allows Total Seal to hold a much tighter tolerance, which means the ring is going to be dimensionally much more accurate. The second ring is a Napier design, which is going to help oil control on the cylinder walls, and our oil control ring pack is a standard tension at 11 pounds, which is going to work great on the street. The set comes with great instructions on how to properly file your ring and tips on proper installation. For our application, we're going to set the top ring gap at 22 thousandths and the second at 24. One of the most crucial steps of ring filing is to properly deburr the ring after filing so it does not damage the cylinder wall or piston. There's several ways to do it, but we use a fine grit India stone. We'll slowly make a few passes to get our desired gap. It's always easy to remove material, but hard to put it back. After the rings are fully cleaned, they are installed on the pistons.
We equipped this block with a set of ARP main studs, which get threaded in only hand tight. This required the block to be a line hone, which was performed by our favorite local machine shop, Shacklet Automotive Machine. A line honing ensures that the main housing bore is round and straight, so the main bearing oil clearances are correct. We've already checked clearances and they look great. After truing up the thrust faces of the bearings, we'll install the caps and torque them following ARP's specifications. 60 pound-feet on the inner studs, 50 pound-feet on the outer studs, and 20 pound-feet on the cross bolts. We're using a comp camshaft with durations at 50 thousandths lift of 239 degrees on the intake and 255 degrees on the exhaust. Lift at the valve is 624 thousandths. Lobe separation angle is 114 degrees. A comp 4-tooth billet double roller timing set goes on, along with a factory chain tensioner.
With the #1 piston installed, we degreed the cam and set the intake centerline at 109.75 degrees for good street manners. With Total Seal assembly lube coating the cylinder walls and ring packs, the rest of the rod and piston assemblies slide in. After torquing the rod bolts to the proper stretch, our 419 cubic inch LS3 has achieved short block status. There's plenty more to go on this engine, but if you want to see any more of our builds, you can go check out our website. Today on Engine Power, the Stroker LS3 receives a slew of high-performance parts, and we top it all off with a supercharger.
Let's see what this thing can do in the dyno cell.
Welcome to Engine Power. Today we're going to be finishing up our 419 cubic inch LS3. We went with an LS3 because this application definitely calls for some weight savings. We have a bunch of great parts going into this thing, and we've already got it to short block status. If you don't know how it got there, here's a quick recap.
The all-aluminum block has been bored and stroked to 419 cubic inches of displacement. Randy Neal of CWT Industries provided us with his Multi-Bal 5500 balancer, which allowed us to balance the Summit Pro LS 4340 forged 4-inch crank to perfection.
The rotating assembly included Eagle H-beam 4340 forged rods connected to custom DSS racing pistons. The Total Seal AP profile rings were gapped, and a comp hydraulic roller camshaft was installed, along with their billet double roller timing set. The cam was degreed with the intake centerline set at 109.75 degrees for great street manners. Finally, we installed the rest of the rotating assembly. On this build, we're going to be using Comp Cam's new Evolution cartridge-style hydraulic roller lifters. These are really cool because they have an internal cartridge that houses the plunger and the hydraulic action of the lifter. This means the bleed-down rates of the lifter are going to be much more precise because they're not affected from distortion of the lifter body. This allows for quieter startup and better performance at high RPM. As an added bonus, they're easy to service because the cartridge can be removed and replaced. To prep our lifters for installation, we've soaked them in break-in oil for a few hours. This ensures that the lifter is properly lubricated for initial startup. They are retained by the stock lifter trays, which are bolted in place at 16 pound-feet. The next thing we're going to do in our LS build is determine the proper pushrod length. Because in this application, we have a bolt-down rocker that is non-adjustable, the pushrod length really isn't going to affect the geometry as much, but it is going to affect the amount of preload in the lifter, and that is very, very critical, so it's something we're going to want to measure. In today's Summit Tech Tip, we're going to show you how to do it. First, the cylinder head is temporarily installed with the head gasket we are using in the build. The adjustable length pushrod, set to the stock length as a starting point, drops in, followed by the stock rocker base and Comp's BSR shaft rocker system. We will zero a dial indicator on top of the pushrod cup, then slowly and evenly tighten down the rocker shaft. The spring pressure will compress the lifter plunger, and the distance the indicator moves is our measured lifter preload. Comp recommends between 50 and 80 thousandths. Ours is well within spec at 58.5. The length needed can vary by application and components used, but ours looks great with a stock length pushrod, 7-inch 400 long. This is the right way to measure for pushrod length in this application, but if you need the tools or help figuring out the right one for yours, you can talk to the experts at Summit Racing Equipment.
On our boosted application, we are going to make sure this engine is properly lubricated with this Melling high-volume oil pump from Summit Racing Equipment. We'll use 3 2/1000 feeler gauges to align the pump drive during installation. These spacers that came with our double roller timing set make sure that there is no interference between the timing chain and the pump. It is torqued in place with orange thread locker, then the feeler gauges can be removed.
We did have to minorly clearance the oil pump and the timing cover itself just to make sure that there was no interference between anything.
Before installing the rear main seal cover, it is crucial not to forget the oil passage dumbbell. We got this ICT billet piece from Summit Racing Equipment, and it is threaded for a 4mm bolt for easy removal. A stock rear cover with an ARP stainless bolt kit seals up the back end. This oil pump pickup came with our Summit Pro LS oil pan kit and with some silicone on the block's mating surfaces. The 6-quart cast aluminum pan seals up the bottom end. It is crucial that the back of the pan and the bell housing surfaces are flush to prevent misalignment when the transmission is bolted to the engine. There you go.
One more?
Yep, one more. This is also held down with an ARP 12-point stainless steel bolt kit. Up next, the stock LS3 cylinder heads are really quite good, but they will definitely benefit from valve train improvements.
And later, we put it to the test.
Now it's time to put some induction on our Supercharged 419, and we will be using the stock LS3 heads, and for good reason. These heads are outstanding from the factory. These are what the old guys back in the day wish they had from the factory with their small block Chevys. They have a 260cc intake port, a measured 69.4cc combustion chamber, which is a really nice high efficiency design. They have a 165 intake valve, 590 exhaust. Now these heads flow up to 300 CFM right out of the box, so they're a great cylinder head for what we're doing. We are replacing a lot of the hardware for it because we wanted some upgrades to make sure it lasts. The stock LS3 spring has about 85 pounds of seat, which is great for stock applications, but for ours we wanted something a little bit more. Our new conical spring has 140 pounds of seat pressure and around 400 pounds of open with an installed height of 1/830. We also got the complementing tool steel retainers, new spring seats, machine locks, and new valve seals. Along with all of these goodies we picked up from Comp, we also picked up Comp's Max Lift BSR LS3 bushed shaft rocker system. These utilize a stock style rocker arm that is a 1:7 ratio, but are on a common shaft that uses the stock rocker stand for better durability, rigidity, and valve train accuracy. We set up every valve train package specifically for its application. Our spring pressures may seem a little high for a hydraulic roller, but it is important to remember that in our boosted application, intake manifold pressure is going to try and force the intake valve open.
Now that Pat has that cylinder head assembled, we can go ahead and get them bolted on. And to do that, we're going to be using an ARP head bolt kit. This one is for a 2004 and later LS, which basically means that the 11mm bolts are all the same length. These are made from ARP 2000, which has a tensile strength of 220,000 psi, which is going to be way stronger than a grade 8 or even an OEM fastener. They also come with a washer that has a chamfer on one side that goes against the bolt head and serrations on the other that goes against the head. This prevents the washer from spinning, turning into a bearing-like surface, and rendering improper clamp loads which can damage the threads or the fastener itself. These are not a torque-to-yield fastener like the OEM ones, and that means they have their own specific torque specs. They are specifically designed to be used with ARP's Ultra Torque Lubricant, which was formulated for consistent and repeatable clamp loads. Again, this means that they can't use an OEM torque spec. The kit comes with specific instructions on the preparation, installation, and torquing of the fasteners, and it's very important that you follow these to make sure you don't get yourself in trouble. We're also going to be using their rocker arm stud kit because, again, this is going to be a lot stronger than a stock fastener and should make it a little bit easier to install our shaft rocker systems. We'll get these bolts prepped, and then we can get our cylinder heads bolted on.
These Cometic MLS 4130 bore head gaskets with a 51 thousandths compressed thickness will give us a measured static compression ratio of 9.49 to 1, perfect for pump gas boost. The 11mm bolts are torqued to a final value of 90 pound-feet, and the 8mm bolts are torqued to 25 pound-feet. Next, the ARP rocker studs are screwed in hand-tight with orange thread locker. Make sure you clean up any excess so it does not go through the engine. We ordered our 7/400 long comp push rods with a 105 thousandths wall thickness from Summit Racing to get them here fast. When installing the rocker shafts, it's important to make sure that all the push rods are seated in their cups before slowly and evenly tightening them down. Up next, we give the LS3 custom paint, a custom supercharger, and then it gets down to business.
The last piece to go on before we paint our engine is this ICT Billet valley cover from Summit Racing. This uses O-rings to seal off the displacement on demand oil ports, so no tapping and plugging is needed to delete it.
If your work area is like ours, space is at a premium, and if you need a safe, clean area for spraying paint, but want something that can be quickly and easily set up, broken down, and stored, this is it.
You may be wondering what I am standing in right now. Well, this is an inflatable, portable paint booth from Mobile Environmental Solutions. This gives you a contained environment to spray pretty much anything that you want to keep dirt, rain, or whatever out of it. It has flow-through filtration system, 360 degrees of ambient light, and this thing gets plugged in and gets set up in under 10 minutes, so it's really cool. What are we gonna be painting? We're gonna be painting our engine in it, so let's get to it.
Before we get started, we need to remove any residual oil, grease, or contaminants that could interfere with our paint job with POR 15's Cleaner Degreaser. We'll also rough up the surface with a red scuff pad. To promote adhesion to any bare metal surfaces, we'll brush on their metal prep as well. After the engine is rinsed and dry, it can roll into the paint booth. To give our power plant a uniform base coat color, we'll brush on POR 15's rust preventive coating. This is normally used directly over rusty metal, but it will also help our engine have a durable finish and consistent color.
This engine is getting a very cool supercharger with a very unique color, and we wanted to match that, so we're going to be using POR 15 engine enamel. POR 15 is well known for their permanent rust preventative coating, and we've already gone ahead and applied that to the engine after we prepped it with their cleaner degreaser and metal prep. Their engine enamel is a really great product that can be brushed on or thinned out and sprayed on. It's good for temperatures up to 300 degrees Fahrenheit, so it's going to be durable and stay glossy in underhood temperatures. It has a really nice finish and comes out glossy and smooth. They have a bunch of factory color options available, and we're going to take a few of those and mix them together to try and match our custom blower color.
When mixing a custom color, it's always a good idea to go slow and use a scale to record how much of each color is used. This makes it easy to make more if you run out or need to match it later on. To get the color that we are looking for, we're using a mixture of Olds Gold, black, and maroon. Thinning out the engine enamel and spraying it gives us a smooth, shiny finish, but does require some extra PPE and makes us glad we are doing it inside of our Mobile Environmental Solutions spray booth.
Now that our engine is fully painted, you can see the color that we were trying to match. This engine's getting topped with a Whipple Gen 5 3-liter supercharger that's been custom powder coated for this application. It has a bunch of cool features like a massive air-to-water intercooler that's going to help keep inlet air temps down. It also has a bypass function that takes less than 1 horsepower to run the blower during cruising to help fuel economy. We're going to top it off with one of their 109mm throttle bodies, and this thing should look really good under the hood.
Along with that, we got an entire front drive assembly from Wegner Automotive. Now this not only will look great, but keep things running smoothly. It comes with everything that we need: the water pump, the alternator, the power steering pump, AC compressor, and all the associated bracketry. To take the coolness factor over the top, we got a set of their custom billet valve covers that will not only hide our coil packs, but give the engine a smooth outer appearance. They even did custom graphics on them just for us.
Let's get this stuff on.
Let's give her a shot.
The Whipple's fuel rails are filled with Holley EFI Terminator X 120 pound per hour flow matched injectors. Using the supplied Allen head intake bolts, the blower is torqued down to 135 pound-inches. Before installing our trick valve covers, we copiously lubricate the valve train with Comp's valve train spray to prevent a dry startup. These Wegner valve covers are in two pieces. The lower seals the engine, and the upper holds and hides our MSD Street Fire coil packs.
Even though we are using an aftermarket EFI system, it still takes its data off of stock sensors. And because this is a fresh build, we needed to get some new ones. So we turned to rockauto.com. We were able to pick up some OE quality sensors for both the crank and cam. This is a 58-tooth crank sensor that goes with our reluctor, and this is a 4-tooth cam sensor that goes in the front of the timing cover. It doesn't matter if you're working on a late model high performance application like we are, or you just want to keep your daily driver going, rockauto.com can keep you on the road.
Included in the Wegner kit was this ATI super damper with a 6% overdrive 10-rib supercharger pulley. The accessory drive is extremely well engineered and came with everything we need, including the water pump, brackets, pulleys, idlers, and the accessories we chose. With a 3700 supercharger pulley and our throttle body installed, this monstrous beauty is ready to hit the dyno.
Up next, things are really heating up in the dyno cell.
Everything is very, very nice. Starts up, very good job on your pre-programming.
Well, yeah, I mean, the Holley stuff makes it really easy because, you know, we have the Holley Terminator X. It's pretty much plug and play. You know, these things always, they just start right up.
Yeah.
You get right into tuning them, and they're usually really, really close. So this one so far is going really well. Love having that Pro Dash there still. That's awesome. Just, you know, it's a great visual, and it's great to be able to actually keep a track on everything, you know.
What we're gonna do is 2,000 to 4,500, 300 a second.
Cool.
Timing looks good.
Yeah.
Everything looks good on fuel. We're gonna be very conservative on fuel, and we're gonna keep it safe. And
we have an idea of how much boost it's gonna make, but also that's one of the variables here is we're not 100% sure. You know, we told the guys at Wegner how much power we wanted to make and what we were doing it with, and so they, you know, scienced it out and sent us the pulleys that we need, so it should be really close.
oh my. Oh boy. Ooh, that's nice. Ooh.
Whoa.
761.7 pound-feet.
Already below 4,500.
Yeah, and 652 horsepower.
That was pretty close on targets and stuff.
Air fuel is nice. That's right at, looks like 12.0 or 12.1.
Yeah, I say we're relatively safe on the fuel because we're still on pump gas, right?
Yes.
So this is a street engine on pump gas. So we're not going to get lean and mean with it.
So it's 10 pounds of boost, basically. What is that?
9.5 pounds of boost. So
all right, so here's what we're going to do.
It's probably going to go up more, I say, as we get more RPM. I'm sure it's going to go up, but it's a good start.
We are not going to tune this thing as far as we're not tuning a race engine.
No.
This is a street engine for a show car.
Yeah, exactly. That's why this thing, you know, we always take pride in making things visually look good, but with like the custom powder coated blower and, you know, trying to get the color matched on the paint and all the really pretty parts on it, you know, we spent a lot of time trying to make this look good under the hood.
We're going to go 25 to 65.
Okay.
At 300 a second and see what she cranks here. Woo!
Wow.
That was pretty mean right there.
Wow. Oh my.
834. That's a lot of power.
I think that might be more than what they wanted, but that's okay.
And it's actually still going up.
Wow.
764 pound-feet of torque. That was a long pull.
Yeah, that
but
was.
air fuel's still safe. 11.8 to 12.1. Very,
Yeah,
very
right
nice.
on target then. Good.
That looks like it's probably almost 12 pounds of boost. I'm looking at manifold pressure.
Yeah, 11.6 at the very top of the pull.
11.6. Okay, we'll take that.
Wow. Yeah.
Aside from just looking at data, we always pull the spark plug out to check the engine's tune. We are showing no signs of detonation.
Everything looks very
Looks
nice.
good.
I'm leaving everything alone. One thing I'd do is let's maybe take
Clean it out.
a little bit of fuel out of it.
I say the timing is probably really close.
Timing's
right? Yeah.
really good. Yeah.
Okay, so right now we're targeting like 11.8, where we're at in the map range. So you want to do just 12.0?
Yeah, just fuzz it.
Yeah, just a little. We don't want to get crazy with it.
We have already exceeded expectations for
That
this.
is true. So once you get everything right on the fuel table, with this software, you can just change the air fuels. You know, it's 2 clicks and you're done.
Yep.
So, all right, we're now targeting 12.0.
Okay.
At our boost range. So
We'll take it. All right. $838
wow.
horse, 763 pound-feet.
Heck
Now,
yeah.
you know what that is? I mean, I'm not a math magician.
that's going to be right on.
That's 2 horse per cube.
Dang, that's good. We didn't see a huge change, but like,
No,
you don't want to
that's-
see a huge change when you're making a small change like that. You want to see a small change that coincides with what you did.
That
so
was
good.
That was a tickle.
Yeah, a little bit of tickle, and we saw a little bit of return.
Okay, so for a pump gas street show car engine, we're going to stop right there.
Yeah, I think that's good. And the big thing about pump gas is that you really have to be careful. I say we're being conservative here. You know, we don't want to step on it. This is going in a car that needs to last. And with that combination, it will. You know, we put really good parts in it to be able to do this.
We could rev it up more, and it'd probably make more power. We could lean it out some. I wouldn't touch the timing. Everything looks great. Everything about this engine is overkill. The Wagner drive, spectacular going on.
yes.
The blower, the Whipple blower, awesome power.
Those not only look good, but they went right on, and they just make the engine.
The important part about this is the tunability with the Holly, right?
Yeah.
So we can peel the air fuels back, we can put some timing in it, it'll run great at partial throttle, light load,
Yeah.
it'll be efficient. This thing will get some mileage.
Yeah,
and
with the bypass and the blower, you know,
Yes.
that takes less than 1 horse to run. So when
Right.
you're cruising, you can lean out the air fuels and actually get decent mileage on it. Yeah.
Right, but if you step on it, it makes the big power.
It's gonna be mean.
All right.
Heck
Great
yeah,
success.
good job. If you want to see more cool pump gas power plants like this one, go check out Power Nation.